Bismillahirrahmanirrahim. In this lab activity, you have two different boards. The Dwingo board, which you see on the screen and you have seen in the lab. This board has these 5 buttons connected here, which can be used to control the speed and direction of the motor. So this board is connected using UART connection. This is the UART connection. It is connected using the UART connection to the mechatronics demo board. So this is the DB9 pin and DB9 connector on the on the mechatronics demo board, and you can connect a cable here. And here you have the DC motor connected on this mechatronics demo board. So you have to use these buttons to control the direction and speed of the motor. So you can use this button for rotating motor to the right, and this one to rotate to the left, and this button to increase the duty cycle of PWM to increase the speed of the motor, and this button to reduce the duty cycle, and that will reduce the speed of the motor, and this button to stop the motor. And this will be the transmitter. The mechatronic demo board will be the receiver. It receives these buttons. It receives on UART this the name of the button which is pressed. For example, here these buttons are named as R, S, L, plus and minus. So when you press this button, you simply transmit the letter R, the ASCII value of this letter. So you can transmit this letter in single quotation mark, and that will be transmitted to the mechatronics demo board. Upon receiving this, the mechatronic demo board, it configures PWM in forward mode. It has to configure PWM in forward mode, and that will rotate the motor to the right. Similarly, if you press the L button, then PWM should be configured in the reverse mode, and S to stop the motor. That means you switch off PWM, and plus to increase the duty cycle. So duty cycle register, ECCP R1L register, you can keep on adding, you can keep on incrementing that register as whenever this button is pressed, and that will keep on increasing the speed of the motor. And the feedback from the motor, which is the speed of the motor, is connected again. It is transmitted back from the mechatronics demo board using serial communication. It is transmitted back to the Dwingo board, and on the Dwingo board you can display it on the LCD screen. Now let us look at the activity. So in the activity, this program, you have to create 2 different projects for 2 different boards. So in the first project, which is for the mechatronics demo board, we are defining the crystal frequency and including the xc.h, config.h, the configuration bits, and there is no LCD connected here on mechatronic demo board, so it is just receiving using UART and then transmitting using UART. And these are some global variables: character to store the letter, the number that you received or the letter that you received from UART, RX flag. This is just another variable which indicates whether you have received something or you have not received anything, and the text for transmitting or receiving. You can define some text for transmitting, and RPM to store the RPM. Yeah, these are all user-defined functions. UART init, UART read, UART write, and UART write text. So you have to complete these functions using the blanks given here. So TXSTA register, find out what should be the bit values if you want to enable the transmission, and for high baud rate and for asynchronous mode. So what should be the bit values here? You can copy that number here, you can write the X number here. Similarly, RCST register, serial port enable, continuous receive enable. Okay, and the remaining bits you can leave them as zeros or as default. Similarly, RX pin is connected on RC7, so this must be an input pin, and the TX pin is connected on RC6, so this must be an output pin. So this is all done in the initialize function, and we are using 16-bit baud rate. So from the baud con register, BRG16 is 1, and based on the equation you have to calculate. Now what is the baud rate? You can define the baud rate in the main function, and it will be passed here as the parameter of this function. Now depending on this you can calculate the baud rate. So for example, let us say 9600. So depending on that you can copy the numbers here. And then the UART read function. So inside this function you have to wait for the flag, the interrupt flag for the reception. So if there is a data received, that means it will be indicated by the reception flag, the interrupt flag for RCIF, which is the interrupt flag for the UART receive. So if it is 1, then you return that data. Here. So you have to write the name of the register here. Which register holds the incoming data? So write the name of the register here. Similarly, so that will be returned back as a character to the main function. Now UART write. Again, here in this you have a character as the parameter. So this character should be transmitted using UART. So before transmission, again you have to wait for the transmit register to become empty. So once again you have to look for a bit here. There is a bit in TXT register which becomes 1 when the transmit register is empty. So you have to wait for it to become 1. When it becomes 1, and then you can copy this CH data which you have from the main function, and copy this CH data to the transmit register, the register which holds the data for transmission. Once again look for it in the block diagram and you can find the name of the register. UART write text is for sending a string. So you keep on sending a string. So this function is already written, you don't have to worry about this. So this function is continuously calling UART write function, which is this function. It is continuously calling this function as long as there is some data inside the array of this function, array of this variable. It keeps on transmitting until it finds the null character. So when it finds the null character, it will stop transmission. So this is all transmitting a string. Then you have the interrupt function for UART. So here we have to wait, or we have to check inside the interrupt function. You have to check the interrupt flag before reading the data from UART. You have to check, look at the flag. If the flag is 1, then read the data. You are calling the UART read function, which is defined above, and that data is saved in the CH variable. And to indicate that there was a new data, this RX flag is set as 1. This RX flag is simply a variable. You are setting this as 1 to indicate in the main function that you have received some data. Now this is another interrupt from the timer 0 register. So if the timer 0 generated an interrupt, then you have to kill your timer 0 interrupt flag bit and copy the value of timer 1 registers in a variable RPM which was defined above as a global variable. Now why do you need this timer 0 interrupt? This is to calculate the RPM. Timer 0 generates an interrupt on every 60 millisecond or 600 millisecond. Yeah, so it generates interrupt on every 600 millisecond. So you copy the data of timer 1 registers. Timer 1 register is working as a counter. It is counting external pulses coming from the motor. So you copy that data and clear timer 1 registers for the next count, and reload timer 0 registers with the initial value that is calculated here in the main. Now inside the main function, configuring oscillator control for 8 MHz frequency, use AD control 1 to configure all digital input pins. In the mechatronic demo board, we are not using the ADC, we are not using any analog input here. So all pins must be configured as digital, and look for the pins for PWM and timer 1. So you have to configure them properly as input and output, and configure PWM mode with all active high output. So for this you have to use the ECCP1 control register, and for the frequency you have to use the PR2 register to calculate the period based on this frequency, and then copy the value in PR2 register. Switch on timer 2 on bit should be 1. configure timer 0 to get interrupt on 600 milliseconds. This will be same as what you have done in the previous labs. And configure timer 1 to count external pulses on this pin. Again, this will be same configuration which you have done before. UART init 9600. Now you are calling the user defined function which is defined above before me. Here timer 0 and UART interrupt flag bits. Then enable global interrupt, variable interrupt, timer 0 and UART receive interrupts. Then we are configuring PWM in full bridge forward mode for the time being, and inside the while loop, continuous while loop, we check for RX flag. So RX flag will be set as 1 whenever there is a new data received from UART. So we are looking at the RX flag. If then here you can use if conditions. If statement inside this you can use if statements, or you can use switch case for the ch variable. So if the ch equal plus, then increment duty cycle by 10. Duty cycle is stored in ECCPR1L register, the high byte. So you can keep on incrementing it by 10 whenever you receive a plus, and if you receive a minus, then decrement it by 10. And if you receive S, then stop the motor. That means you can set the duty cycle equal to 0, and you can kill here, or you can switch off PWM, and by switching off timer 2 as well. And if R is received, then configure PWM in full bridge forward mode. So once again, we have to, if you switch off the motor by switching off the timer here, so in this case you'll have to switch on the timer as well again after configuring the PWM. Similarly here, for the reverse mode, you have to configure it in the reverse mode, and you have to switch on timer 0 or timer 2 if you have used timer 2 before to switch off PWM. Okay, then convert RPM to string. Where is the RPM? RPM, you get the RPM from timer 1, which was copied here. Timer 1 registers were copied to the variable RPM. So convert that into the string format using a sprintf function, and then transmit the string by UART. So to transmit the string using UART, you have to use the UART write text function. You simply have to call this function, and in the parameter you send the RPM. You send the RPM variable, and it will transmit the RPM to the Duengo board. Now, in the other project which you write for the Duengo board, here you need the configuration for 4550. So this will be a different configuration than what you have done before for 4580. So configure the switch, this microcontroller to get in 4550. Then we are using an LCD here, so you have to use #flow density.h. And these functions, UART init, UART read, UART write, and UART write text. Copy these functions the same, write them in the same way as you have done in the previous project for the mechatronic board. You have to write them in the same way. And inside the interrupt functions here, you have only one interrupt here from UART. You don't have the timer interrupt. So whenever there is an interrupt from UART, you are simply calling the UART read function, and you set the RX tag as 1. Now once again here, configure all the digital input and output, and latch E1. This is for the LCD actually. So this bit E1 is connected to RW of the LCD pin, and you have to make it 0 for the LCD to work. And initialize LCD by calling the LCD init function from the LCD .h to the file. Enable port B pull ups. Okay, and then because the buttons are connected on port P, so you have enabling port P pull up for that. And UART init, initializing the UART, and enable UART to receive peripheral and global interrupts after keeping its flag. So you have to enable all these interrupts related to UART. Then inside the continuous while loop, check for button plus. Now you have 5 buttons, so you'll have to keep on checking input from all those 5 buttons. So you have all these 5 buttons, and they are connected on button L is connected on RB0, button R is connected on RB1, S is connected on RB2, plus connected on RB4, and minus connected on RB5. So you have to use conditional statements to check which button was pressed, and based on that you simply transmit the name of the button. That means you are simply transmitting these letters plus, minus, S, R, or L. You are just simply transmitting these letters in single quotation marks using the UART write function. Okay. Then if anything was received, if the RX flag is 1, that means if anything was received on UART, then that means the RPM was received from the mechatronic demo board. So you have to clear the LCD and display the received characters, which is the RPM. You have to display that on the LCD screen. And you can, after completing both these programs, you can compile them and you can load those hex files here. So this is 18F4550 microcontroller on the Durango board, and this is 18F4580 microcontroller on the microcontroller demo board. So once you load the hex files here, you will see the program will be working. So let's look at the working of the program. Okay, so let me press R. So it configures the motor in the reverse and the forward mode or the right direction, and we can increase the duty cycle. The duty cycle increases very slowly because it's only plus 10. So I'm incrementing it by 10. You can increment it by 50, for example, to make it faster. And you can see the motor is rotating slightly towards right. Okay, it's very slow, so you have to keep on increasing the duty cycle to make it faster. So this is how the program works, and the RPM is sent back from this microcontroller to this microcontroller, and it is being displayed here on the LCD screen. So you have seen the RPM by 100. It has increased now to 3. It was 1, 2, and now it became 3. So this is the explanation of the activity. You can complete the activity by completing the template, and you can submit it online on Blackboard. وآخر دعوانا أن الحمد لله رب العالمين. السلام عليكم ورحمة الله وبركاته.